Welcome everyone to this orientation to Databricks for new users. My name is JP Powers. I'm a research data scientist in the Trax Data Science Lab. We have a simple outline for what we'll be covering today. First, I'll talk about what Databricks is and what it's designed for. Then we'll walk through many of the key features you'll want to become familiar with as a new user. This will be especially geared toward people who will be starting to use Databricks in the SHIRE, which is a new system at UNC I'll talk about more later, but this will also serve as a general orientation to the Databricks platform. Let's start by talking about what Databricks is. Databricks is a cloud-based, highly scalable data science platform, and we'll go through this piece by piece, starting with cloud-based. So cloud computing refers to when you outsource your computing work to faraway computers, which you can then access and manage through the internet. And this is in contrast with on-prem or on-premises computing, where the computing work is actually done on hardware that you own or your organization owns and maintains. So when we say that Databricks is cloud-based, it means that your computer is just running a web browser. Then when you run code, process data, or perform analyses in Databricks, those will run on cloud computing resources that you will manage through the web interface. And we'll get into more about those cloud resources later. Moving on to our second part, highly scalable. This refers to the fact that Databricks is built on Apache Spark, which is an engine for efficiently handling big data. Apache Spark is an open source software product. As I said, it's referred to as an engine for big data processing. More specifically, Spark provides a special framework for writing and executing code that is far more efficient for processing large amounts of data than what you could achieve with regular Python or R, for example. So Spark achieves this through several methods, including distributed computing, in-memory computing, and various optimizations. And we won't go into each of these, but I'll share a quick illustration of the distributed computing framework, which is one of the core features that powers both Spark and Databricks. So when you run code using Spark, you're communicating directly with a computer called the driver node. The driver node won't usually run your code. Instead, it's responsible for dividing up the computing work across a bunch of other computers that it's connected to, the worker nodes. And then the driver node is also responsible for assembling all the results that come back from the worker nodes. The worker nodes connect to where the data are stored, usually some type of distributed storage system, and they read in just the data they need to do their share of the computing workload. They can also write new data files into storage when that's part of the code. So using this distributed computing framework and the other methods I mentioned, Spark facilitates very efficient big data computing. But it wasn't originally designed to work in a cloud context. So in 2013, the creators of Spark, which is again an open source product, formed the company Databricks and built the Databricks platform, which is a commercial product. Now, Spark serves as the core computing engine in Databricks, but Databricks brings Spark to the cloud and adds a suite of data science tools and services around it. And while Spark was always focused around big data, Databricks has also added a strong focus around AI work, although it can still be used for other types of work as well. Now, we've already touched on this final part of our description, that Databricks is a data science platform. So you can use it to develop and run code, build and run machine learning and AI models, and manage and query large data sets. Now, in the groups we work with at UNC and within the SHIRE, the specific type of Databricks we use is called Azure Databricks. So this is the Databricks platform integrated into Microsoft Azure, and Azure is Microsoft's cloud ecosystem. So Databricks has also been integrated into some other cloud providers' ecosystems. So if you need to look up information about Databricks as it's implemented in the SHIRE, you'll look for Azure Databricks specifically. Now, I've been mentioning the SHIRE, so let me say a little bit more about that. The SHIRE stands for the Secure Health Informatics Research Environment, and this is the new secure environment for working with data from the Carolina Data Warehouse for Health. that many CDWH researchers are going to be using moving forward. The SHIRE has a variety of software options for managing and analyzing data, but Azure Databricks is going to be the main platform for advanced data analytics needs in particular. Now, a couple notes about the target users of Databricks. Databricks is designed to be a comprehensive enterprise-level platform that can be used by data engineers, data scientists, data analysts. It's really meant to handle all of the data needs of an organization. And it's designed to support very large organizations, especially those that have machine learning and AI development needs. Nevertheless, it can still be used by individuals and small teams. But I think it's helpful to understand Databricks from this perspective because we'll see that Databricks is really overpowered and overfeatured for how many projects will be using it in the SHIRE. So it's helpful to start thinking about which features are relevant for you. Now with that, we're getting ready to transition into our live demonstration of the Databricks platform. But a few quick points before we dive into that. Databricks is a powerful platform and it's very complex. There are so many functionalities you can learn about, it can be overwhelming. Keep in mind though that in the SHIRE, several functionalities in Databricks have been disabled, generally things that involve communication over the public internet, which is to maintain the secure nature of that system. And lastly, note that Databricks uses cutting-edge technology and it has a strong focus on AI work. And this means that the platform and its underlying technologies are constantly in flux. Things change frequently in this space. For example, features get deprecated, new features get added, the names of things change, the interfaces change. This does all make Databricks harder to learn, but you are better off learning to use a tool that's still being very actively developed like this one, rather than one that's no longer being developed. And with all those disclaimers out of the way, we're going to do a brief walkthrough now of some of the features of Databricks you're likely to encounter and use as a new user, especially if you're using it in the SHIRE. So we're going to start with some of the more core features of the platform, and then we'll branch out into various more specific topics. As I mentioned, you'll be using a web browser to access Databricks. So I have my web browser open here, and I've gone to my particular URL to get to Databricks. Just to note, I'm not demonstrating Databricks in the SHIRE here. I'm demonstrating another instance of Databricks that I have access to, but it will look very similar. Now, when you first land in Databricks, you'll hit the Recents page, where if you have objects that already exist, it'll show you the most recent objects you've accessed in case you want to jump back into one of those. But let's back up and talk about the Databricks workspace. So a Databricks workspace is an environment for using Databricks that is accessible to a specific set of users. And in the SHIRE, we provision one Databricks workspace per project. So when you land in Databricks, you'll be within your Databricks workspace. And then if we actually access the workspace button from the sidebar over here, that will open up the workspace browser. And this browser is where you'll organize mainly your code files, not so much data files. And we'll see in the Create menu from the right here that there are a variety of other objects you can create though. So you can create folders to organize your code, you can create the code notebooks, other simple text files, and a handful of other object types as well. Now, when you land in the workspace browser, it'll show you your home directory. Every user in the workspace has a home directory. And if I wanted to share something from my home directory with another user in this workspace or vice versa, that can be accomplished using the share functionality here. And if another user shared something with me, that would show up in my shared with me section here. You can also have objects and folders that are shared with all users within a workspace. So those would show up in this shared section here. But let's go back and take a closer look at a code notebook. So I have a demo notebook here we can look at. I really enjoy working with these code notebooks in Databricks. They have a lot of really nice features. They're similar to Jupyter Notebooks or Google Colab Notebooks if you are familiar with either of those. So you'll write and run your code in segments that are called cells, which are these rectangular outlines you see here. These notebooks also support Markdown if you want to add more organization around your code, like you're seeing with the headings I've added here. And all changes that you make to your notebook will be immediately auto-saved. And you can see the last time a change was saved at the top here. And if you ever need to roll back through those auto-saved changes, you can do that by accessing the version history from the right panel over here. There are a lot of other very useful features you can access from the main menus at the top here. So for example, under the File menu, you have a few different options for how you could export a copy of your code notebook. So it defaults to an IPython or Jupyter notebook. You could also export a snapshot of it as an HTML file, or you could export a source file. So in this case, this is a Python notebook, so it would export as a basic Python script if you chose this option. There are a lot of handy actions under the Edit menu here. You can see there are keyboard shortcuts for a lot of these as well, so you might get used to using those to access these actions more quickly. There are also buttons around the code cells themselves for accessing a lot of these actions. Under the View menu, you can see a variety of options to control how the editor appears. You can select between a light and dark theme and select more specific themes. You can also control which options show up in the left and right side panels and various other options here. Under the Run menu, we can see that you have quite a few options for how to run code within your notebook. So you can run the entire notebook at once. You can just run certain sections of cells. You can even run specific text within a cell. Now, some of these options are grayed out because this notebook is not actually active right now. But if it was, we would see this clear state option here. This is an option I use quite a bit. This is if you want to erase everything that has currently been created in memory in your coding session if you want to start from scratch again. And then finally, under the Help menu here, there's a handy page of all the keyboard shortcuts that you have access to in the editor here. Now, once you start to get used to the features in the code notebooks here, I recommend that you take a few minutes, you go up to your user settings here, go to the Developer tab, and scroll through all of these options that you have and make sure they're set the way that you want them to make your coding experience much more enjoyable. Now let's talk a bit about coding languages in Databricks, as Databricks is primarily a code-based platform. Every code notebook has a default language which you assign for it. We can see that in the drop-down at the top here. So in this case, I have assigned Python as the default language for this notebook. Other options would include SQL, Scala, or R. And the default language means that whenever you type new code into a code cell and run it, Databricks will assume that code is written in the default language unless you tell it otherwise. And the way you could tell it otherwise is using magic commands. So I'm demonstrating that here. So let's say that I've pulled in a data frame of data here, and I really want to run a SQL query on this data set. The way I could do this is using this special Python command here, which I have to run to convert my current data frame into something that SQL can view. Then in the next code cell here, I'm using the SQL magic command, this %SQL. That then tells Databricks, interpret the code in this cell as SQL code rather than the default Python code. Now, if I wanted to then use the results of this SQL query with the rest of my Python code in this notebook, I could then run another special Python command here to convert the results from the SQL query back into something that Python can then understand and interact with. Now, I generally avoid using magic commands in notebooks, and I recommend you would do the same just because of this back and forth that we've seen here, where you often have to convert your inputs and outputs as you're passing things back and forth between the languages, and it's not always very intuitive. There's also often an alternative where you don't even need to use the magic commands. For example, in this case, there is a special command in Python where I can run a SQL query on my data set and save the output without actually leaving the Python language. I can just insert this SQL query within this special function here. Now, as we saw, some of the main languages you can use in Databricks are then SQL, Python, and R. If you choose to use SQL in Databricks, the specific type of SQL you'll be using is called Spark SQL. And this is nice because it automatically supports that distributed computing framework of Spark, which we looked at earlier. On the other hand, if you want to use Python or R, if you want to leverage that distributed computing framework, you have to learn to use certain libraries within those languages. So for Python, you would need to learn to use the PySpark library, and for R, you would need to learn to use the Sparkler library. And these libraries contain functions that you need to use to actually leverage the computing power of Spark. Now, Python is actually the most used language in Databricks. So as the developers roll out new features, they tend to preference support for Python especially. So if you're new to Databricks and you're not coming in with a strong language preference, I do recommend you consider using Python, as this will generally provide you the maximum functionality of the platform. I mentioned earlier that this code notebook was not currently active, and that's because to accomplish anything that requires actual compute power in Databricks, such as running code in a code notebook, you need to connect to a compute resource. So that's what this gently pulsing icon up here is letting me know, that I've not yet connected this code notebook to a compute resource. So if I were to click on this button, it would show me any applicable compute resources I could potentially connect this notebook to. And once I've done so, then I would actually be able to run code in this notebook. If you want to see and manage all the compute resources that you have access to, you would come over to the compute page here in the sidebar. And we can see here there are a variety of tabs on here because there are a variety of types of compute resources and various places in Databricks that you would need to connect to these different types of resources. There are also different cost structures for each of these. So one important distinction to be aware of in this cost of Databricks compute resources is serverless versus classic compute. Serverless compute in Databricks refers to compute resources that are managed and billed for by Databricks directly, whereas classic compute refers to compute resources that are managed and billed for by your cloud service provider. So in this case, Microsoft Azure. Now in the SHIRE, users can create small personal compute for themselves. They can do that with this button here, and you could use that for simply developing your code. If you need more powerful compute clusters that can actually leverage the distributed computing power of Spark we've talked about, an admin can potentially provision that for you in the SHIRE. There are several other types of compute we see here as well. For example, job compute. This probably won't be as relevant within the SHIRE. This is a type of compute you could attach to scheduled jobs, which would be more common in long-term production systems rather than the more one-off project-based analyses that we'll tend to be having in the SHIRE. Next, I want to say a little about data management in Databricks. Databricks has very complex data management controls and functionalities you can potentially access, but in the case of the SHIRE, probably will not often be needed. These include things like Unity Catalog, which is what this catalog button leads to in the sidebar, also Delta Lake, Delta Tables, and more. So these features may be of use to more advanced users, but we won't be covering them in this orientation for new users. Again, these types of features are really meant to facilitate large organizations controlling users' access to content at a very granular level. In the case of the SHIRE, we recommend simply storing your data that you need to access from Databricks in the data lake that comes with your SHIRE workspace, and then you can access those data directly from there in your code. And this will be one of the most cost-effective ways to work with Databricks in the SHIRE. Now, the way you would set this up is there's a file that exists in your shared storage drive in your SHIRE workspace, and this file contains the name and account key for your data lake. You could then come to your code notebook and configure these details in the notebook itself. For example, I can use a configuration function like the one shown here, which will tell Databricks, I have a data lake with this name, and this is the account key for it. And then once I've run that, I can use a particular format of path, like what's shown here, to then access objects within that data lake in the code here. Now, this type of hard coding of account keys directly into a code notebook is a practice that's generally discouraged, but this will work fine within the specific context of the SHIRE because of the way the system is set up and how it's being used. There are also ways to store your data within the Databricks workspace itself, but this is generally not recommended, and some of those mechanisms for doing that are being deprecated. So the intended setup is that your data live in some storage outside of Databricks, and you just connect Databricks to that external storage, as we've talked about here. So those are some of the core concepts of Databricks that I wanted to cover, and now we're going to move on to some more specific topics, starting with large language models, or LLMs. There are different options for how you can use LLMs in Databricks, and each one has a different cost structure. Note that all of these, though, are generally very expensive compared to other costs that you can incur using Databricks. So if you are interested in using LLMs, I do recommend you start out with caution to make sure you don't accumulate large costs unexpectedly. And the way that you'll set up access to these LLMs is through model serving endpoints. And these can be accessed through the serving page at the bottom of the sidebar here. One of your options would be to set up an endpoint that connects to an external model, a model that's hosted somewhere outside of Databricks. So for example, you could connect to a GPT model that's being hosted directly by OpenAI, or you could connect to a Claude model being hosted directly by Anthropic. This type of LLM access is disabled in the SHIRE though, but you can also have LLM endpoints that are hosted within Databricks. And one advantage of these is that in addition to using these LLMs as they are, you would also have the additional option of fine-tuning these LLMs. There are two main cost structures associated with these. One is a pay-per-token structure, and the other is called provision throughput, which is something you could set up, again, using this create serving endpoint function here. And what this essentially does is allow you to reserve a specific amount of compute capacity for an endpoint, especially for the purposes of a production workload. I won't go into any more detail about LLMs here because the Trax Data Science Lab has another upcoming seminar which will go into more detail about using LLMs in Databricks. I'm going to jump back now to a feature you may have noticed earlier when we looked at the Workspace browser. Under the Create menu over here, you see that we can create folders. We can also create something called Git folders. These are what enable you to link content in your Databricks workspace to GitHub or similar remote Git service provider for backup and full Git version control. Note that these Git folders are disabled currently in the SHIRE for security purposes, but I'll demo setting these up briefly in case we do later find a solution to set these up in the SHIRE, or if you're using Databricks somewhere outside of the SHIRE. So to get these set up, the first thing you would do is go up to your user settings, and this time you would go to the linked accounts page. Here we can see I already have Git integration set up on my account, but if you were here for the first time, you could open this Add Git Credential button. And in here we see that there are a variety of Git service providers you can choose from. And once you've chosen one, you might see multiple options for how you can connect to that provider. Once you finish setting up your connection and Databricks and your remote Git service provider are able to fully talk to each other, then in GitHub, for example, you could create a new repo. And once you have, you could come back to your workspace, go to create a Git folder, and then you would paste the URL for your new Git repository here, select the Git provider and provide a name for this, and set up your Git folder. Once you have a Git folder, you can create code notebooks inside of it, like the one I have here, for example. And when you have a code notebook that is in a Git folder, that notebook will have an extra button at the top that we see here, and this is for the Git controls. So if I were to click on this button here, this is where I access controls for committing new changes to the notebook to the remote repository. Now, at the moment, it's showing that there's no changes to the file, so there's nothing I could do. If I were to add something here, and then go back to this button, we would see it would detect that there's been a change. This is the particular file within the repo that the change was made in. I could type a commit message here, and then I would be able to commit and push this change to the remote repository. Next, let's talk about some of the AI tools in the platform. So one of the main ones is the Databricks Assistant, which is an AI assistant you can chat with as a coding partner. So you could open that using this icon here, for example, and it will open this whole chat window with the Databricks Assistant, which you can then use as a coding partner. This is another feature that is disabled in the SHIRE, but there are some AI tools that are enabled in the SHIRE. For example, there's an AI predictive code completion tool. This is called the Automatic Assistant Autocomplete, and this is a very powerful tool that can read the code and comments that are currently in your notebook, and it will try to predict what you're going to type next whenever you start typing. And it offers these predictions in chunks that you can accept or reject one at a time. This tends to be very accurate, and it can be especially accurate if you provide it guidance by commenting in your code what you're intending to write with the code. So this tool can save a lot of time, especially with well-commented code or when you're completing some kind of repetitive coding task. Of course, I recommend that you don't just accept any completions that the tool offers blindly, but that you do carefully review them for accuracy. Then there are a couple other tools that take action whenever you run code that fails. So one of these will try to determine if the code may have failed due to a simple syntax error, and if so, it will offer a suggested fixed version of the syntax. Another version of this tool actually opens the full Databricks Assistant when your code fails and tries to diagnose and offer suggestions for fixing the code that way. I have found these tools to be less accurate than the code completion, but you can control all of these, whether you have them enabled or not, up in your user settings. In the developer tab, you'll find toggles for these there. Moving on to our next group of features, there are a number of SQL tools available in Databricks, and these are clustered under the SQL heading here in the sidebar. These are in addition to simply writing in SQL within your code notebooks like we looked at earlier. Now, using these tools tends to require that you set up your data similar to a database within Databricks. And again, this is something that you might be more likely to do in a long-term production system. And this sort of functionality is really meant to let you emulate something like a relational database management system within Databricks. So for example, if we look at the SQL editor page here, this will look similar to SQL editors from other platforms you may have used with SQL in the past. You would use this editor for interactive data exploration, and then if you run a query that you want to save, you could save it here, and then all of those saved queries will get stored under the queries page here. Now, in order to use these SQL tools, you have to connect these to compute, just like other features within Databricks, and you would do that with the menu here. You do have to connect these to a special type of compute though, which is called a SQL warehouse. And the name is confusing because it's not actually storage. In this case, it's a type of compute just called a SQL warehouse. So those can be set up under the SQL warehouses page here, which is actually just a shortcut to the SQL warehouses tab within the main compute page that we looked at earlier. Now, lastly, let's talk about some features for doing machine learning work in Databricks. In your Databricks notebooks, the runtimes that run there already include many common machine learning coding libraries. So you already have access to a lot of those libraries in your regular coding. But Databricks has also created some other tools to assist with machine learning workflows. And the main one is called MLflow. This is a tool for managing machine learning model development and use through the full life cycle of machine learning models. It's meant to make machine learning development more transparent and more auditable. What you can do with this tool is essentially store extensive details about every aspect of your machine learning model development. So this includes model training, the parameters of your model, the performance metrics of various runs, the different versions of the model you've created, and everything that you log about your machine learning models gets stored in the experiments page under the AI ML section of the sidebar here. Now, if you're using some of those popular machine learning libraries in your code, MLflow might actually auto-log a lot of information for you without you having to do anything. But you can also control it in a more manual way, which I'm demonstrating further down in this demo notebook here, where you could import the appropriate libraries, start an MLflow run, and then throughout here you can tell MLflow exactly the sorts of things you want to make sure it's logging. Some other features for enhancing machine learning workflows are that you can save features for your models that you might reuse later for other models to a feature store, which is what the features page takes you to here. You also have the option to register full models to the model registry, which is what the models page goes to here. And then these would be available later on here for production-ready deployment. Here I've provided the URL to the official Azure Databricks documentation. If Azure Databricks is what you're using in particular, then you'll want to make sure this is the documentation you're referencing rather than the AWS Databricks documentation. Unfortunately, our teams don't have the capacity to provide comprehensive training and support in how to use the Databricks platform in general. So if you want to dive deeper into getting started with Databricks, you may need to reference this documentation or find other training on your own. If you're a SHIRE user though, just note that we are about to launch a website for the SHIRE, and this website will contain some resources that will cover specific aspects of using Databricks within the SHIRE. And lastly, I'll note that as of the time of this recording, our group is about to have another seminar which will be specifically on using large language models in Databricks. So if that's a topic that you're interested in learning more about, that's going to be available on the Tracks Data Science Lab YouTube page later this month.